Welcome back. In this lesson, we're going to be taking a look at how to set up our lab equipment, our materials and stuff like that for a particular reaction that we're going to be using to sort of evaluate mass-mass relationships, limiting reactants, things of that nature. And these techniques can be used for any type of lab that we're doing. It's just that we're focusing on one or two particular techniques on this one, along with some others that we have used before. Obviously, we have our ring stand and our iron ring and our gauze, our iron gauze right here that has a little ceramic part in the middle for heating. We'd have a Bunsen burner. Eventually, obviously, we're going to have to heat something. We need an Erlenmeyer flask. We need a funnel. We're going to need a beaker. And then in this particular lab, we'll be using some copper 2 sulfate and some iron. But we could do the same type of lab with any materials. These are just the particular ones here. So the techniques will work for any type of reaction similar to this. These are just the particular reagents we'll be using in this lab. And then of course we will need some distilled water or some deionized water. Distilled water for our purposes will work as well as deionized water. For certain things, deionized water may yield better results, but with the equipment we have here, and I've tested this before, the distilled water is going to work just fine for our purposes. All right, and then of course you'll always need some goggles or safety glasses. All right, and then stirring rod, also quite helpful. So let's just jump into this. So you have to get some copper 2 sulfate, and you're going to be making yourself a copper 2 sulfate solution. So here's where molarity equation is going to be used. You're going to need that to help you do some calculations in this particular lab. And so you would need to obviously have a scale with a beaker. If you put that beaker on there, obviously you know how to do mass by difference. You'd open this up, you'd put some in there, you'd measure out whatever you need to based on your recipe, on the instructions that I provided for you. So you're going to mass that out. You would need to get some distilled water so you can make your solution. Go get the amount of water that you need, put that in there, obviously, and then you would stir it all up. You're good to go. And then at that point, you should be familiar with the fact that a lot of times heat needs to be utilized to catalyze a reaction, to move the molecules faster along, to really speed up that reaction. The colder it is, then the slower those molecules are moving, et cetera, et cetera, et cetera. So you're going to end up needing to put that up, that solution up here. You're going to heat it up, and you're going to want to heat it to where it does not boil. If it's boiling, you have a chance of things, splattering and getting everywhere, and that's the main reason for it. Don't cover it up. That would pressurize it, and you would probably break whatever lid you put on there, like a watch glass. You don't do that. You never use that. You never use a watch glass when you're heating. You're going to heat that up. So now, if you think about it, you have a warmer copper 2 sulfate solution. Those molecules are moving much faster. All the crystals have obviously dissociated, and they are now part of the solution. So you've got aqueous cations and anions that are moving around in there. At this point, take a different type of cation, in this case our iron filings, and you're going to add a certain amount into there. And the recipe that I give you, the instruction I give you, tells you how much. Again, the focus for this lab is determining your limiting and excess reactants, which mathematically you can theoretically figure that out even before you get into lab. But if not, you can do that while things are cooling down. You can do all that. But I recommend coming to class prepared with those calculations, and so that you can focus your time in lab on doing the actual cooking, right? So after you've heated that up, then you're gonna add those in, and then you should see a reaction happening. And this is a particular class of reaction. You should notice that there's a displacement and replacement of these cations, and you should notice a different type of metal precipitating out of the reaction and falling down to it. And depending on how warm your solution, depends on the rate of that reaction and how quickly you will see those cations literally precipitate down and fall, etc. So once all that is done and your reaction has proceeded as long as it needs to, you follow your instructions, it tells you all of that, then you would have this solution, you would have all of this here. So if you think about it, the reaction has happened, but everything is mixed here into this one beaker, right? So you have to separate all that out. To do that, we are going to use a method called decanting. And so here's where your Erlenmeyer flask becomes very handy in your funnel. Okay, so at this point here, now what you need to do is you need to figure out how to get your solution out of here and separate out your solid substance from your aqueous substance. So you've got a filter paper, and this grade filter paper works for the lab that we're doing. It'll capture all of the solid substances here, and if you fold it correctly, and none of them will move through the funnel, which is what we want. So this is round, obviously, right? And so we've got to figure out how to get those two things to fit. So there's a classic way of doing this. You basically take your filter paper and you fold it halfway one time, gently close that, and I've had some students say in the past, well, so it looks like a taco. I guess it's folded like a taco shell, right? So yeah, it is. It's folded halfway. Now you've got half of a circular piece. Fold it again end to end, and now you have something here that begins to look like this will fit in a funnel. Now at this point here, you'll notice that you have the opening like this, which is the halfway mark, and then you've got right in here and here. Close it all the way. Go to one of those openings that's right there. Not the middle part, but an opening right here. You'll notice that now it fits right there into the funnel. If you let go of it, see how it pops up right now? But there's a little trick that we can use to keep that from happening. If you think about it, it'll make sense. But your funnel, if your filter paper is much too large for your funnel, kind of the way this one is, if you take it out, one thing you can do is fold it back the way you see it. Take a pair of scissors, and you can go back and you can say, okay, I only want this so high up off of there. So you say you look at this and you say you just want it to be halfway up. You do want the filter paper to come up off of there a little bit, just in case when you're pouring you don't get any spillover. And it'll help trap any of those solid particles that maybe rise up a little bit higher. So it's always good to have a little bit extra. You don't want it to be exactly flush and level with the funnel, because then the spillover, some of that solid substance could then go on the other side and then just literally filter down into your Erlenmeyer flask. So we'll go about, say, maybe halfway. All right, you make that call, at least halfway, and then you just sort of follow the curve of the funnel paper. Put that over there in the trash. You go back, you open this up, and then that fits. Now you still got that problem where this is happening. Here's where stuff we learn as kids is very helpful. You're going to be using a lot of this anyway. So now, if I just take a little bit of water, then the water itself literally pushes and helps it to stick to the funnel. And now it's good to go. You don't have to sit there and hold the funnel, which you don't want to be doing, considering that you're going to be pouring this warm solution. And to be on the safe side, you don't touch the solutions anyway, right? It's all part of lab safety. So now at this point, we have to get this. We have to decant this solution into here and get all the solid particles in here as well into this funnel. So the way you do that is you take your glass stirring rod, you hold it over, you have the spout of the beaker, and you hold it so that it's sitting there laying flat like that. With one hand, you hold the beaker, put a finger underneath the beaker, and then you're basically cupping the beaker, and I've got my index finger right here on top of the glass stirring rod. And the glass stirring rod, you can see, is on top of the spout coming forward. When you do that, Now when you come over here and you start to pour, what happens is instead of all of that liquid, a lot of that liquid pouring on the side of the beaker, you don't want. What you do is, and if it's too far forward, you just go to the back and you pull, put your index finger down, and you'll notice that it's holding right onto there. And so now you come over about the halfway mark and you start to pour. And when you pour, remember, you need to commit. When you pour, just don't gently, I mean, I'm not saying dump all of it, but when you commit, you'll notice, like, if you're at home somewhere and you go to pour something out of a container like this, if you pour slowly, you'll usually get a lot of stuff dribbling on the side. Well, we're going to use that. We're going to use that knowledge. You're going to come here and you're going to sort of start pouring forward, and you're going to want to use the forward part of the glass stirring rod as a guide, and you're just going to sort of pour. You're going to be near the top, and you're just going to sort of have a nice, even, gentle pouring. And as you do that, you'll see it fill up when it gets to about, say, 2/3 or so in height full of liquid. Pull back, stop, let it continue to do what it's going to do. Let it continue to filter through. Eventually, as you start to pour, you'll start to see some of those solid particles come out as well, and that's perfectly fine. You just let that happen. You just let that happen. You just keep going, and you just let that do its thing as the solution decreases in the funnel, how high it is. You can just kind of keep pouring. Then there comes a point where you've poured out all of that, and if you think about it, you'd probably have some substance stuck to your glass stirring rod, and a whole lot probably still in here. Well, that's easily taken care of. Hold the stirring rod over the funnel, and then with your wash bottle, you can wash all of that off. Now you've got that stuff, the solid substance. You can see it collecting right inside your filtering apparatus. It's a fancy way of saying the funnel with the filter paper. Now you've got all of this in there. Well, let's think about this. You're going to have what is called a rubber policeman. What it is a glass stirring rod with a little, like, a rubber part on it. And what you can do is now you just start pulling those pieces forward. And you put them into there. And then obviously onto here, you would just go and you would rinse those pieces off. And then you still have some particles in here, perhaps. At this point, if you just hold this at an angle like this, and you take your wash bottle and you spray, you can hose all of that out of there. Next thing you know, all of your solid particles are in the filter. Once all that's done, you return this safely away from the edge. You let it continue to filter out, and then once it is completely filtered out, you would have separated your solid substance from your aqueous substance. The aqueous substance, you follow the guidelines for disposal for the aqueous substance here, and that'll be in the lab instructions and or in the safety data sheets that you should be looking at before you come to class. And I'll help try to remind you of that as well, but if I don't, you'll know where to find the information. Now at this point, if you look at your instructions, or even if you think about it, we got to figure out what's the mass of just that stuff here. The whole purpose is to figure out, what's our error? How much product did we make? And obviously, we've made two products. We've made a solution that is a different type of solution, and we've also made a new metal substance, a new solid substance, and we have excess of a solution as well. So now at this point, what you have to do is, once that drains completely, if you have the mass of your beaker, okay, and then at this point now what you do is if you take your funnel that has your paper, your filter paper on it, if you take all of this, and now what you're going to do is you would put it into a drying oven. I will have that set up in the lab area at the right temperature, and it's going to look like an incubator basically, because you can use it that way. And you put it in a drying oven, and it's going to then dry the remainder of the liquid that is here. It's going to dry the remainder of that, and once that dries, well, you would then be able to, and cools down, You would then be able to take all this, put it on a scale, get the mass, and then use mass by difference for all of your equipment to figure out what's the mass of the substance in there, and we then now have our readings for our expected yield, our actual yield, right? So we've already calculated what we expect to get, our theoretical. Now this is our experimental, our actual yield. Now we can do the math to figure out how successful were we in this, and what's going to be my grade, right? Because remember, ultimately your grade is going to be linked to the success of your procedures, right? And then that's it. You're familiar with these techniques. I just wanted to kind of give you a nice visual of that to help out for many people. Sometimes this might be the first time that they've done multiple techniques, and when you're going to be in the kitchen cooking, so to speak, sometimes it's very helpful for you to have just a little bit of guidance. And so I hope that helped. I hope that did provide you some guidance. So come to class prepared. We're going to get this done. We're going to be safe. We just know we're going to be dealing with hot liquids and fire and stuff. So there's potential hazards in glassware, so things can break. So remember, always safety first. I'm looking forward to working with you in lab on this. I'm looking forward to seeing your results. So it's always good talking with you. Stay curious, and I will see you in class or another video lesson soon. Bye.